I've been working on a special side project to upgrade my toolbox into a standing desk workstation, and I started getting serious using 3D printed Gridfinity bins to help organize all the tools I like to have immediate access to. After spending quite a bit of time going through some trial and error, I wanted to pass along the different methods I use both inside and outside of my Fusion CAD software to hopefully give you a path forward with customizing your tool setup, especially given all of the incredible feedback I received on my first video where I was showcasing the Gridfinity add-on in Fusion, which I'll have linked in the description below if you're curious. Today I'll cover some simple yet incredibly helpful tools I use to streamline my design process, the methods I use to approach getting my custom shadow boxes made, and some helpful tricks to color code your organization system to take it one step further. So without further ado, let's jump right into it. Alright, so first things first, there are some tools you can use when designing your bin system that will be extremely helpful to tackle your setup. Assuming you have access to a 3D printer to make your bins, you can download and print a Gridfinity ruler. The ruler is set to the same 7mm base units and the 42mm grid spacing that match the standard bin system, and it makes for a quick and easy way to measure your parts and even your existing bins to figure out your sizing. I highly recommend this one I found that's designed by Engineering by Coincidence on MakerWorld, which gives you the option to print directly on a Bamboo Labs 3D printer in a single color or multicolor options that come set up for the standard AMS mappings. Next, I really can't recommend this enough, using a simple piece of graph paper I designed using the MathPolate website that gives you a 4x6 grid unit graph with 7mm spacing, which came in extremely handy for laying out my different parts to generalize my bin layout, and was even more helpful when bringing pictures of my tools I wanted to model into Fusion, which I'll go into details on later. So you can either download the finished PDF I already created, or feel free to navigate to the website and set this up for yourself in case you want to tweak any of the line sizing or color settings. Here's the settings I use that you can replicate as a starting point for what you need, but special note, I did have to tweak the small grid line spacing even though it was excluded. I just wanted to note it here in case you get the same error message I received. Finally, I recommend using a set of calipers if you have them, or even just a ruler, preferably something that can measure in metric to avoid having to convert units. I even recently found this tape measure that has really well-defined metric units along the tape, since I spend a lot of time designing in metric just for convenience. I'll have that linked in the description as well if you're interested in picking up one of these off of Amazon. Now, as a last-minute alternative worth mentioning, you can simply use pieces of already 3D printed grid sections. I had some of these extras lying around, and I realized that these make for a perfect way to calibrate sizing on things in a pinch to help with your shadowboxing efforts as well. Now, with all of those basic tools out of the way, let's jump right into the different methods I use to shadowbox my parts to see if anything shakes out as a helpful approach on your end. Now, the first option is to just do nothing. Now, hear me out. In my mind, I'd like to custom tailor every little thing, but in some sense, that's not always necessary for most items. I found that I wanted to offer my space some flexibility over time, since I always inevitably end up changing what things I like to use the more I spend time at a certain workspace. For that reason, I ended up using basic 1x4 grids to hold all of my writing utensils, and even a spare 1x3 bin to collect random tiny objects that accumulate over time. I like that these are easy to find if you want to skip modeling altogether, simply by going to the Gridfinity wiki page, or even on your favorite 3D printing repository website like Printables or Thangs or MakerWorld. If you want a good example, I came across this big repository on MakerWorld that had tons of options for directly importing into your Bamboo Labs printer. On the one side, simple bins are easy to source and or quickly generate using the Fusion extension, and the hollow bins especially will use way less filament over time. However, that's probably not all you came here for, which leads me into my first way to start customizing things. Now, the first layer of customization I found somewhat helpful is just using the custom bin configuration settings in the Fusion Gridfinity add-on, but there are some special things to note here. For one, I highly recommend using printed graph paper here to tackle your setup, since it's not very straightforward at first glance. The example I'm using here is a simple bit and extension storage tray that I wanted custom spacing for the different grid pockets on. To tackle this, I first outlined the overall grid sizing for the tools I have laid out, and I found that I'd need a 3x3 bin size to hold everything. Next, I started marking out halfway points that could help me approximate where I could start drawing evenly spaced intersections for everything, and kind of just repeating that halving process until I landed on a subgrid that would allow me that flexibility, which ended up being a 2x4 internal subgrid to properly set the tool slots. Then I hopped into Fusion, and this is where it's important to set up your parameters just right. So just like my first Gridfinity video, I enabled a preview checkbox down at the bottom so I can see the real-time updates. Once that's good, set your overall bin size, which for me is the 3x3, and your desired bin height. Then make sure your bin type type is set to hollow and whatever other bin features you wish, whether that's the notches on top or without. And then we'll navigate to the bin compartment section. And for these, I just set my custom subgrid width to 2x4, or you could do 4x2, depending on how you want to have it oriented. After that, I start plugging in my start locations and bin width and length to carve out my set of bin pockets for my specific application. You can also use other extension features like adding in a scoop like I did here for my ratcheting screwdriver design. You'll just have to be careful to design your grid layout in the appropriate direction since the scoops can only generate in one way. This method alone could easily take an entire video if I'm being honest, and if you do decide to go this route, I highly recommend popping over to the extensions wiki page, and from there go back to the home page to look at some specific example setups to get the idea of how to incorporate this, which I found tremendously helpful. Noting that you probably are looking for maybe a slightly easier option, let's transition over to using AI to help us tackle this with a higher level of efficiency. I, like so many others, discovered this method after watching the full video on this by CNC Kitchen, which I'm going to link in my description to really dive deep on this method if you'd like. I had some mixed feelings about going this route, mainly in terms of the correct approximation of the tools when the tool generates the cutout. The idea is pretty straightforward. You take a standard piece of A4 printing paper and take a picture of your desired tool on or around the paper, since the tool will use the A4 paper to calibrate the rough sizing of everything. In my experience, I found that good lighting and trying to get a decently level view of the picture helped more on certain objects. The next thing you'll want to do is send the picture to your computer and upload it directly to the Tooltrace website. And from there, it'll prompt you to help detect the paper and the tool that you are using. And then you can adjust the settings on the left toolbar to set this to Gridfinity design or the grid sizing and other custom features you wish to add to the design as well, such as a finger slot to enable you to pull the tools out of the tray. Once all your settings are mapped, you can view the design layout and then eventually export the file once you are satisfied, which luckily they offer multiple formats, which I really appreciated. Now on the downside, I found that some of the tool cutouts came out really poorly, which could have been due to the picture I took or the way I helped identify the tool features in the software on the website. Regardless, my fix for this was just downloading the step file directly and uploading it into Fusion, which offered a couple of benefits. For one, I could make adjustments to the cutout itself to open it up and add certain cutout features to make it easier to remove the tool just by using a sketch and splining around the area I wanted to improve. But also with the example of my calipers, I was able to upload the step file and add in additional features to the bin, including my tiny screwdriver for swapping batteries and a little rectangle cutout to hold rulers and spare batteries. And I even ended up adding this little offset to balance the end of the tool properly when it's set in the cutout. Overall, this method works decently well, and I think it makes for a quick and simple way to get a customized look. I also like that the file exports with a colored insert directly from Tooltrace. This actually brings me to another really important point that someone brought up recently about getting parts to fit together. When I first used the AI tool to make my holder for the Allen keys, I had my suspicions that the cutout wasn't actually accurate. Luckily, using your 3D printer, I found a way to quickly test this out just by slicing a cross section of the part to check it before you commit to an entire print. To do this, simply bring your part file into your slicing software, use the cutting tool in the toolbar to slice the part at a section that approximates your closest fit, which for me was anywhere along the Allen key cutout in the vertical direction. Then for an added bonus, you can remove as much material as you'd like by repeating your cut to size it down, or you can go to your scaling tool, disable uniform scaling, then set your Z height as thin as you'd like to print out a simple silhouette of the tool. As you can see, this ended up saving me quite a bit of plastic by testing that first design and seeing where it was interfering with the tool, and informed some design features I was able to make in Fusion using my sketching tools to clean up the extrude for a more polished final part. Now, again, I'm not saying the AI tool is bad, but over time while making all of these custom boxes, I found myself converging on just using my CAD software directly to get the best results all around. This does require the ability to use CAD, so I totally understand wanting to try out some of the previous methods, or you can always navigate to the gridfinity.xyz website to dig deeper into generators and Tooltrace to see if you can find what you need. However, given that my viewers typically want to get more comfortable using Fusion, and to me I found it to be the most robust method that I use, I'm going to cover the ways I tackled this designing more parts directly. If you're the kind of person that is looking looking for ways to improve your surroundings by designing custom tools, I can tell you enjoy building your problem-solving skills and expanding on that skill set, which is the perfect segue to today's sponsor, Brilliant, an interactive learning app that helps me stay sharp and unleash my potential in concepts I constantly find myself needing to use for real-world applications. Brilliant helps you excel in math and computer science with visual, interactive problem-solving and personalized practice to help you level up on the topics you are looking to grow with. Brilliant believes everyone is a math person. It's the way we learn math that can feel confusing and hard. Here you don't just memorize formulas, you get hands-on with concepts until they make sense. Brilliant guides you to those aha moments, helping you develop the intuition and problem-solving skills to figure things out on your own. Brilliant's comprehensive catalog takes you from foundational math through algebra all the way up to college-level calculus, with more courses being added each month. I really enjoy the user interface while working through different interactive problems and have found that I've started enjoying diving into the concepts at a foundational level and not feeling like I'm trying to memorize formulas just to get by. To learn for free on Brilliant for a full 30 days, go to brilliant.org/TyWritings, scan the QR code on screen, or click on the link in the description. Brilliant's also giving my viewers 20% off an annual premium subscription, which gives you unlimited daily access to everything on Brilliant. And now, let's jump back into customizing shadow boxes for Gridfinity. Now, the easiest way to jump into this again is by taking a picture of your part on the Gridfinity graph paper, because it not only helps you visualize the size of the overall box that you're going to need, but also gives you a great method to calibrate the size of the picture when you bring it into Fusion to help guide your sketch. So starting with this first example, I placed my X-Acto on the grid, and I found that taking a picture a little bit higher and zooming slightly while using the crosshairs to stabilize the picture made for tight accuracy of the part's outline and reduced some of the distortion from being too close to the part. From there, simply upload the picture to your computer and then we'll go jump into Fusion. Now, quick note, as many of you may be aware, Fusion just rolled out a massive update to the early 2026 release of the software. So I'll be doing this starting from the intent-driven design interface that pops up, which hopefully is more helpful. So once we're in Fusion, we'll create a new hybrid design, which is important to be able to use the Gridfinity extension, and then we'll save the part in our desired project folder. We'll then activate the Gridfinity add-on and immediately make sure we have the preview enabled. Now let's simply create a 1x3 bin at your desired height, and I'll set the bin type to solid, and that's it. Next, let's import our picture to help with our sketch using these simple steps. First, just navigate to the Insert dropdown and select Canvas, then Insert from your computer. Select the photo you wish to use, then select the top face of the solid bin where we wish to make a cutout for our tool. At this point, you can use the arrows to drag the canvas around, but you may notice the picture size is way off, so let's first scale that properly. So for now, just hit OK. Then to scale it, we're going to navigate over to our browser. We're going to drop down the subfolders in your browser for the part, drop down your canvas, and then right-click the image you just pulled in and select Calibrate. So luckily for us with this example, we use the graph paper and we know that each little square is exactly 7 millimeters apart. To calibrate, you zoom in using your cursor, then select two edges or intersections of the square, and set that distance to 7 millimeters and hit Enter. Now that the tool is scaled appropriately, this is where it's best to set the final position. To do that, right-click the image again and hit Edit Canvas, then use the combination of the pull arrows and the rotation bubble to position it accordingly. You can also set exact values for the movement direction by selecting the direction you wish to go, then typing in values to get close to where you want it. Once you're happy with the placement, hit OK. Now, the final piece of this is sketching your outline to make your cutout. So we'll create a new sketch and select the top surface of the bin where we wish to cut out the part. If the canvas is in your way, you can always hide it and re-enable it in the browser tree as needed. Once we've started the sketch and we've ensured that the image canvas is still turned on, you can use your normal sketch tools to approximate the tool's parameter for your extrude. With some tools, you can simply put in lines and arcs if the part is relatively straight. For me, I ended up using the spline tool since it offers the most flexibility to get more regular features. With the spline tool, just know that if you hit escape at any point while you're clicking through your spline points, it will erase everything you just splined together, which is a feature I've griped about before. So the safest method is to make sure you connect all your points to ensure the sketch is complete. Once you have your outline, you can tweak your different sketch features to get a decent approximation of the tool profile, which I highly recommend giving yourself a decent offset so that your part has a lower likelihood of interfering. Once that's done, simply hit the extrude tool, cut your part to whatever depth you'd like, and it's ready to go.
You can also use a revolve on certain tools to get a highly customized cutout that will fit your part nearly perfectly.
For starters, this is where it's really helpful to have a set of calipers or even your ruler or tape measure to get an accurate measurement of the tool you want to revolve. Simply take measurements of your overall part, which I'm doing here first to the universal socket I have, and get a good idea of the diameter and the length of the part. Then I'll pop into Fusion and use the bin I already created earlier that has the 2 cutouts for the bits to use as my blank slate to start my design on. I'll start a sketch on the top face, then sketch in my dimensions of a side view of my part, given its diameter and its length. Something to note here, I always fudge in a decent amount of offset around the part, somewhere between 0.5mm to 1.5mm, depending on the part and the complexity of the geometry. That way the part can easily slip into the cutout. It's also important to define the location of the cutout relative to the edges of the box to fully define your sketch. Once that's complete, you technically could do the revolve at this point, but I wanted the cutout to sit a little deeper into the bin to utilize some of the excess volume. So I start an extrude and extrude my sketch to a comfortable depth to give me that buffer. After that, I then move into my revolve operation. For this, I select the tool inside of the cutout as my sketch plane and start a sketch. I'll use my project tool here by hitting the P hotkey on my keyboard and then select the entire rectangle as my projected outline. Last, I will put in a center line so that I have a good reference to do my revolve operation. Then hit OK. Now I activate the Revolve tool up in the Create tab. I select the sketch I already have created, and Fusion automatically detects the center line to perform the revolve around. Make sure you have the revolve type set to cut, then hit OK. Just like that, we've created a nice revolved cut for our socket, and we can repeat this exact same process for our other adapters as well. Lastly, I'll show you a slightly different approach to do this for my screwdriver. I took a picture of the screwdriver laid out on the grid paper, then upload it to my computer. From here, I repeat the process I used for the X-Acto knife by importing the canvas, setting it on our desired face, calibrating the size using the squares, then I position the screwdriver using Edit Canvas. From here, we will activate a sketch again, but this time I'm going to show you a little trick. I'll start by first putting in a center line down the center of the part to save me some effort with our revolve, since this is a nearly perfectly symmetrical tool. Then starting at the top of my construction line, I sketch a spline all the way around half of my tool with an offset and make sure to connect it to the bottom point of my center line. From here, I adjust my splines to make sure everything looks okay. Something to note here, I'm breaking a bit of a cardinal sin by not fully defining my part, but this is pretty typical with using splines since they are a bit of a pain to define parametrically, so this is totally okay in this context. Once that's done, we'll extrude that half of our desired cut to a comfortable depth. Now, let's finish the feature out. First, let's use the mirror tool to populate the other side of the extrude. Then, same as before with the socket, let's select the bottom face of the extrude, start a sketch, then use the project hotkey P to get the entire perimeter of the cut. Last, let's put in a center line along our part, then hit OK. After that, let's activate the Revolve tool, select the sketch that I intend to use, then use the center line we populated. Make sure the Revolve type is once again set to cut, then hit OK. Just like that, we've got a couple of methods to make our custom designed cutouts in Fusion. My parting wisdom here as well, make sure to incorporate some slots for your parts as desired to give you an easy way to pull your parts out. And it's a really nice last step to perform some beautification by adding in some fillets and chamfers all around your part. You can also add in things like text or symbols simply by throwing in some additional extrudes if having some identification for your parts are desired. Now, to polish off this video, I'll quickly run through the 3 different techniques I use to add multicolor to my shadow boxes to give you some options for how to color your 3D prints. Option 1 is just making an insert for your tool. I like this option because, for one, you don't have to have a multicolor printer to do this, and it makes your bins flexible in the sense that you can switch up your colors over time if you'd like, or if one gets damaged or marked up for some reason, you can swap in a brand new one quickly and easily. To do this, you'll want to have a nice flat face to create your cutout on, which for this example, I'll use the Allen key bin I created previously. Simply start a sketch on the top face of the bottom of the extruded cutout, then use your project tool by hitting the P hotkey to project the entire perimeter of that face. Next, use your offset tool and select your projected sketch. I would recommend offsetting at least 0.4 millimeters or so to make sure the insert fits properly into your bin. This can vary depending on the complexity of your cutout. Feel free to test out sizing as needed to get it just right. Next, extrude the offset sketch up to your desired height. Then make sure your extrude type is set to new body. This is important so that you create a separate body you can 3D print. Then hit OK and send your model to your 3D printer to print however you would like. Remember, in Fusion, you can select the body you want to print, right click on it, hit save as mesh, then export it directly to your 3D printer slicer to get started right away. Now, option 2 is getting into multicolored printing using your 3D printer slicing software in a couple different ways. The way I found myself preferring to do it was to
just set my printer to swap colors after a certain height. This not only will save you from wasting too much material using color swaps, but it also works if your printer is only equipped with single color printing. In your slicer, you can drag your slider on the right-hand side of the screen down to your desired color swap range, then right-click and select color change. This will tell your 3D printer to either swap colors in your AMS or equivalent if you have multi-material extrusion, or for a single color printer like my P1P, it will stop the print at the height and give me the opportunity to change the filament out manually to finish the print in the second color. The hybrid approach to this is just using your color tool in your slicer and setting a height range for your primary colors. Then if you need to also have multicolor blended into your design like I did with my ratcheting screwdriver, you can also just paint specific small features to give you the ability to still save some color swaps and use it only when needed. Finally, the last option that is pretty common is to just use your color tool in your slicer to paint geometry in the bin, which honestly, this works pretty well for flat faces that only require the color for a couple of layers and won't bog down your print time with color swaps. I hope that some of the methods I showed here will help with whatever customization you are trying to tackle for your setup to finally give you that clean and custom look for your workspace. If you have some helpful insights into ways to improve this workflow overall, please share it down in the comments so that others may benefit from different perspectives on how to streamline their setup. If you're interested in more design and maker content, please check out these videos I'm floating here on the screen, and I look forward to catching you on the next episode. Until next time, thanks for watching.